Under the Tools menu there is an option called Masks, and here we can build a mask around any particular waveform and count the number of occurrences that the waveform changes. So in this example we're going to build a mask around a narrow pulse, but occasionally a wider pulse occurs. So we want to see how many occurrences of the narrow to the wide pulse occurs. So I'm going to stop the acquisition at this point and then build a mask around the narrow pulse and then detect when the wider pulse occurs. So to build the mask, again we select the Tools, Mask menu, and then select Add Mask. And here we can generate the mask, and we can select the time and voltage sensitivity. So I'm going to leave the time at 20 microseconds, and I'll just decrease the voltage sensitivity to 50 millivolts and then generate a mask and then apply the mask test. Close it. So here we see the mask that has been built around this particular pulse. We can again stop and start the acquisition here. So I've just cleared the acquisition. So at the bottom now we have a table, and we can see the number of occurrences of the waveform that has been acquired. So I'm going to run the acquisition and acquire some pulses. So we've just run it a couple of times there. So there we've seen 10, 16 captures, etc. But we can see how many are failing outside the mask. So if we could stop at that point. So here we can see there's been 41 occurrences of the capture, and 20 of them have failed, have been the wider pulse. So in fact by running this test we can see that it's about a 50-50 split between the narrow and the wide pulses. It is possible to edit the mask shape, and this is done with a right mouse click and then selecting the Mask menu and edit the mask, and then we can see the table of all the points that have been built. So here we can see the individual points, and it's possible then to pick up each individual point and move them with the mouse. So for example we could make the mask much wider, in fact so it included every pulse that was occurring in this particular example, and then we can close it. If you needed to change the lower mask, you can again select that. So now we could again run this test, and here obviously now we're going to be seeing no failures because the mask is including the wider and the narrow pulse. So there we see a wide pulse and it has not failed the mask test. Mask tests can also be used in the frequency domain. So now I'm going to apply a different signal to the input, and I'll just do an auto set on it. So this is in fact a repeating clock signal, and now we're going to go and select the spectrum mode. So here we see a spectrum of the signal, and again we can change the bandwidth. So I'm just going to look at say up to 2 megahertz, so we're going from DC to 2 megahertz display, and again we can build a mask around this particular signal. So again we select Tools, Mask, and again add the mask and generate, and then again we can change the sensitivity. So I'll change the sensitivity down to 20 kilohertz and again use 50 millivolts, and then generate a mask and apply. So here we see now a mask in the frequency, and if we run this we can see that this signal is pretty well repeating. There's just an occasional little components in the noise. So this is a very good test to see if any extra frequency components appear in the selected bandwidth.